Hello everyone. In the previous video, we explored some basic functions and their graphs. The purpose was to build a foundation for understanding graphical transformations such as reflection, dilations, and translations. Now we know how different algebraic operations on a function lead to specific type of transformations. These can include the vertical shifts, moving the graph up or down, horizontal shifts, in which the graph moves left or right, vertical stretches or shrinks, in which we make the graph taller or flatter, horizontal stretches or shrinks, making it wider or narrower, vertical flips, it means that reflections over the x-axis, and horizontal flips, it means reflection over the y-axis. With this understanding, we are now ready to dive deeper into how each of these transformations works and how they combine to create more complex graphs. But before that, in this video, we will learn the modulus function and related transformations. Let's dive in. So first of all, we will discuss what a modulus function is. So the modulus function is also called as the absolute value function, and it is defined as the fx is the absolute value function, let's define, is equal to the modulus of x, and it is defined as negative of x when I have x less than 0, 0 when x is equal to 0, is positive x when x is greater than 0. This notation is indicating that the vertical bar around this x, it is the fancy way to write this whole definition. It means whenever you see this modulus x, we have to understand that it is negative x when x is less than 0, it's 0 when x is equal to 0, and when x is positive, I have to take x. So this is the definition of mod x. Now, how do we draw the graph of this mod x? Let's see. So you will see that to draw the graph, I need three definitions. First, I need y is equal to minus x when x is less than 0. It means we are drawing the graph of y is equal to minus x line when I have x less than 0. So let's try to draw this part first. So suppose I have this axis, the x and y axis, here we have, and you know that when we have to draw the y is equal to minus x line, I will see that there's a slope of line is a negative 1 and the intercept is 0. So if I see the intercept is 0, means the y-intercept is 0, it must pass through the origin with a negative slope. But I have to take this line up to origin only. It means the line which is passing through negative 2, 2, negative 1, 1, and till 0. At 0, it is not here in the definition. But as you go further, at 0, the value of the function is 0. It means I can fill this 2 so that it will follow this definition of the function. Now I have y is equal to x, and it is a line which is passing through 1, 1, 2, 2, and so on with a positive slope, or is a line making an 45-degree angle with the x-axis, and this is also 45 degree. So this is the line we have drawn for left definition. This is the line we have drawn for right definition, and we combinedly say that this is the graph of modulus x. It means the graph is a v-shaped graph at the origin. So this is the graph of modulus function, and we will see what will be the consequence of this modulus when we apply this modulus definition on other functions. By the way, there is another way to understand or draw the graph. Let's try to see. Suppose we have the line given y is equal to x. So let me write it another way to understand everything. The another way to think is, suppose I have the function given fx is equal to x, and I want to do the composition of this function with the modulus function, and we will see how the modulus function is giving the effect on this function. So let's take this fx is equal to x, and by the way, you know the fx is equal to x is an identity function. So this is our identity function, and this is y is equal to x, and I am applying the modulus to it. It means now I have to think what is the effect of mod on that. So what is the meaning of this? It means whatever the value of x you'll take the positive side, it will never change, because for positive x, it will give you the same x what is already before. Means for any x we have, whatever you take, you will get the same thing. But for every negative x, you will get the positive value of the previous quantity. Suppose I put here -1, it will give you +1. Suppose I put you -2, that will give you +2. So if you see a point here, it will not give you the same point. Now it will give you the image of that on the other side of the x-axis. It means if I'm taking this point here, I have the image here. If I'm taking the point here, I'm taking the image will be there, and so on. It means you are taking the image of this entire part of the graph, which is below the x-axis, in the opposite side of the x-axis. It means you're taking the image of it, and that will be the complete graph of y is equal to mod x. So one thing is actually sure from here, that if we have to draw the modulus of any function, we can just draw the graph of function, and the portion what we see it is below the x-axis, we have to take the image of it in the x-axis to the up side, and whatever this image you have taken for the object, or whatever the portion you have taken, that will not be anymore in the picture. So this is the way. Let's just take one more example and we'll see what is my point. Suppose you want to draw the graph of modulus of x cubed. So what we do, first I draw x cube, and then I want to draw the modulus of x cube. So let me just write in this way, mod of x cube. So I have the x cube graph. How does the graph of x cube look like? It is already we have seen. So this is the graph of x cube. In the last lecture, we have discussed everything. And now I want to draw the graph of mod. So you see that this part of the function here is below the x-axis. I have to take the image of it on the other side of the x-axis, mean the positive side of the y-axis. So basically, I'm taking x-axis at the mirror. So this is our mirror I have, and I'm taking the image of it into that mirror. It means the image will look like that. And this part and this part together will confirm the graph of modulus of x cube. And why it is happening, you have to just understand. Not only draw the graph, you have to also understand why it is happening. Why it is happening? Because whatever point you take from the positive direction of the x-axis, suppose I'm taking 1, 0, the point will be 1 here only. So at 1, this is giving 1. So there is no such actually problem with the positive direction of the x-axis. But when you take any point on the negative direction of the x-axis at -1, Originally the value was -1, but since there's a mod sign, it will give you the value 1. It means this point will jump off. So this will give you the image of complete graph to draw the graph completely. And so this is the image. So how do we draw the image of it? I have this function. I'm drawing the image like this. So the graph will look like this. And already I have this portion. So all together, now it will confirm the graph of mod of x cube. And the portion what we see in the bottom part or the below part of the x-axis, that will be not anymore. And that is the modulus of x cube. All right. Let me just take one more example and then we'll go for the other problems. So suppose you have to draw the graph of modulus of sine x. So I have function sine x, and then I want to draw the graph of another function, that is the mod of sine x. So I have the graph of sine x, you know. So this is from 0 it will start. At pi by 2 it will hit 1, at pi it will go to 0, at 3 pi by 2 it will hit -1, at 2 pi it is again 0, and so on. So I'm only drawing the one cycle from 0 to 2 pi, and in the backward direction I'm taking only -pi. So I'm actually taking -pi to 2 pi only. Let's try to understand this first. This is going to be 3 pi by 2. This is going to be -pi by 2, and so on. So you know the idea, how to draw it. We take the image of whatever portion we see below the x-axis in the x-axis. The image we have to take in the x-axis. So I have this part below the x-axis and this part below the x-axis. So we take the image of it and it will turn like this. It will take the image of this, it will turn like this. It means the graph entirely will look like that. And also the previous part was there. We don't have to disturb it. It is already there in the positive part. So we don't have to disturb this thing. And that completes the entire graph of mod of sine x. And also this part is not anymore. So this part we have to exclude it. So in this way we draw the graph of modulus of any function. So what is the general idea we can take from here is, I have any graph given, or any graph if I have for any function y is equal to fx. If I want to draw the graph of y is equal to fx mod, what we take? We take the image of portions of the graph which are below the x-axis. And after taking the reflection, delete the portions what is below. You know what I mean. So suppose you have any random curve like this, and I don't know how it will look. Suppose I have this kind of random function. So we have to only observe that or where it is below the x-axis. So you can see that this portion is below the x-axis and this portion is below the x-axis. So I have to only take the image of this, keeping the previous portions which is already above the x-axis. So now we'll complete. So I'm taking the image of it, so it will look like that somewhat. And again I'm taking the image of this, so it will look like that somewhat. And now this whole thing will complete the graph of mod of fx. All right, so this is the idea of drawing the graph of mod of fx. Now there is one thing you can see, that if I try to draw the graph of, let us see this part, this one can also argue that how do we know that it is not getting reflected this side of the graph to the right side, to the left side. This is also true in this scenario also, in some, not for all. So that is actually going to give you the idea of this function. So I have a second transformation of such kind, that how do we draw the graph of y is equal to fx, not y equal to fx, from y is equal to fx to y is equal to f of mod x. So let's try to understand again from the identity function, and we will generalize it. So I have an identity function again, and this time I'm going to apply not the modulus function from outside. I'm thinking the modulus part is, or the modulus sign is applied from inside. It's a very difficult to identify here, but let's try it. So how do we try this thing? This thing. So the thing is, when we are applying this modulus from inside, it means that I'm thinking this way, that whatever you are taking the negative direction of the x-axis, it should give you as if you have taken the positive value of the x. Try to understand. Previously, what was happening, when you are taking the modulus from the outside of the function, there's a difference between y is equal to mod of fx and y is equal to f of mod x. If you are taking the y is equal to mod of fx, it means whatever value we achieve as a negative, we have to take a positive value. It doesn't matter the x input is a positive or negative. Y is equal to modulus of fx. It means I need to see only which portion of the graph is below the x-axis, even if the x is positive value, and then we reflect it. So here what I'm thinking, that the value is acting, the input is always acting as a positive value. It means whenever you see any negative portion also, negative x also, it will act as if you have substituted the positive x. So in this example, it's a little bit confusing, but I will give another example to understand it better. Suppose you have -1 here. At -1, the value of the function will act as you are taking the +1. And at +1, you have the value 1. Correct? At -2, you are taking the value as if you are taking at 2. It means now the reflection is happening sideways, not up and down. It means the portion what we are thinking to take the reflection of is right to the y-axis, and you are reflecting it to the left also. And that will complete the graph. The graph is a symmetrical graph, and that is why you are not identifying the difference between these two. But let's take another graph and then you will see that. Let us take the function like this. I am taking, let's say, this function. Okay, I don't know what the function is, definition is there, but we will see how the graph we can draw for. So you see what is happening. This is y is equal to f of x, and I want to draw the graph of y is equal to f of mod x. So see what is happening. Suppose I'm taking this -1 there. It means it will act as f of 1, but f of 1 is here. It means this point, this height is the same at -1 also. It means this height is same at this point also. So you can see that this graph is in fact like this up to this portion. And if you complete it, you are taking only the reflection of the right side to the left side, and this part which is already there is not anymore. So what do you observe there? The observation is, suppose you want to draw the graph of y is equal to f of mod x. What we take? We have to take the reflection of the portion of the graph which is right to the y-axis to the left. So take the right portion to the left. And I'm saying that to take the right portion to the left means don't have to shift it. Take the reflection, I mean to say, of right portion to the left, and ignore all the portions what you see to the left of y-axis earlier. So earlier, whatever portion we see to the left of the y-axis, we have to ignore it. We have to only take the right portion to the left as a reflection. So in this way, the modulus function will act, and the definition of modulus function you understood. Now let's do some question, and we'll see how this modulus function is applied, or the modulus transformation is applied to solve the question graphically. So I have a question first. Question number 1 is x cube plus 1 mod is 2x, and we have to find the number of solutions. So what we could do is we can draw the graph of x cube plus 1. So you know that the graph of x cubed is like this. I'm only drawing the schematic diagram, not up to the scale. And then I have to add, this is y is equal to x cubed. I am aiming at drawing the graph of x cubed plus 1, and then I want to take the mod. So first of all, I have to take the shift. So where it will go? At 1 unit above. So here only I'm drawing it. So this point will be 1, and it will be like this. And this is the graph of y is equal to x cubed plus 1. And now I have to take the modulus of that thing. So to take the mod of any function from outside, you know that we only see whichever portion of the graph is below the x-axis and take the image of it. It means now I identified that this is the portion which is below the x-axis. I have to take the image of it. I'm taking the image like this, and already I had this function, this part above the axis, so I don't have to disturb it. By the way, this I drew it up to there, but it is not like only will stop there. You know that it will go down also. Therefore, it will also go up, and where it will stop, we don't know. So for sure, I have a 2x, y is equal to 2x I have to draw. So let's draw the y is equal to 2x line. And you know that y is equal to 2x line has a slope 2 and the intercept 0. It means it will pass through the origin. And by the way, this part is not anymore, so I'm just deleting it. So this is the portion I have left, and this is the graph I left, and also this part I'm deleting it. So this is the graph I am left with. Now I have to think that which is this point. This is 0, 1, and this point is what? Minus 1, 0, because when you substitute negative 1 at the left hand side of this thing, this will become 0. Now the y is equal to 2x line is a line passing through origin with a slope 2. That will go like this. The slope is 2, by the way. So at 1 the value is 2. So at 1 the value is 2. We have to think whether it is also for the function, or a function on the left hand side is there or not. You can see that at 1 the value is 2 here also. If you substitute x equals to 1 there, that will be also 2, and here also x equals to 1, that will value is 2. It means it should touch the graph at 1, and the line will look like, let me choose a different color. Yes, the line will look like this, and it will be a tangent to this point, and after that it will be going upward, and there is no such interaction after this. So there's only one point of intersection at x equals to 1, because when you take any number more than 1, the left hand side will be higher than the right hand side. Suppose I'm taking 1.1, so 1.1 to the cube is more higher than 3, and it's adding all 1 also, so therefore it is not possible. So there's only one solution in this case. So by the way, you can also do it analytically, but only I'm giving you in this whole series graphical understanding. Next, this question tells that again we have to find the number of solutions. So I have first function, you can see, is the modulus of x, and after that we are intended to draw modulus of x minus 1. After that we are intended to draw the mod of x minus 1 whole mod. After that we are drawing mod of x minus 1 whole mod minus 2, and finally we take the final mod. So let's start from the basic. The basic function is our mod x. So I have this line, x and y axis, and here I'm drawing the mod x graph. You know that this is the graph mod x. The second part is we have to draw the graph of mod x minus 1. It means the previous graph will be shifted 1 unit down. It means the graph of mod x minus 1 will look like there, and we also identify where they will hit the x-axis and the y-axis. So we are shifting it down, so for sure this will become 0, 1, and this will become negative 1, 0, and this is 1, 0. You can look from this basically directly also. Now I have to take the mod of this whole thing. So you can see that if you take the mod, the portion what you see here in this part will be reflected, and so I have the graph. It looks like this will go to the 1, 0, and again this will come down for that portion. I'm taking the reflection, and again it will goes up. So this is the graph of mod of x minus 1 whole mod. So I'm overwriting, doesn't mean that these are the two graphs here. It's just to highlight. All right, this point is negative 1, 0. This point was 1, 0, and this point is for sure 0, 1. So we have drawn this graph so far here. I have to now shift this whole graph 2 unit down. So you can see what is happening. Let's try. So what we can observe here, the observation is that this 0, 1 will be shifted 2 unit down. It means it will go at negative 1. So let's try to create a W kind of thing at negative 1. And this origin, not the origin, the x-axis will be shifted 2 unit down, so it will go at negative 2. It means this point, what you see at negative 1, 0, this should give you here, and this is going to give you negative 2, not minus 1, minus 1, negative 2. And this will give you 1, negative 2, and so on. So let's draw it. So here I'm drawing in this color. So this is our 0, negative 1, and I want to draw the W part of it. So let me take it like this, like this. This point is negative 1, -2. This point is 1 comma -2, and again we draw like this. Now the point is, how can you identify that where it will hit the x-axis again? So how do we identify? The x-axis will be hit by the graph. For that, the y should be 0, correct or not? So you can identify from this portion also that at what number this whole thing will become 0, because you have shifted this graph to it below. This will become whole 0 if I write this thing will become 2. And this will become 2 if I have mod x is equal to 3. It means this must hit at 3 comma 0. This must hit at -3 comma 0. You can also identify this whole thing by just looking at the graph, because this portion or this line, you can see it is passing through now 1 comma -2. So if you draw a line passing through 1 comma -2, I can write a line as y plus 2 and x minus 1. And the slope of the line is always 1, because we have not adding or just multiplying any coefficient to the x. So in each transformation, the slope is consistent for every piece of the line. So that is 1 only. So I have to substitute there y is equal to 0 and x will come automatically 3. So this is the one way thing also. And the other portion, if this is 3, we identify, of course, if this is 3, identify this will be by symmetry -3 and so on. So this far we have drawn the graph of mod of x minus 1 mod -2. Now I have to take the final mod, and you understand what will the final mod. I'm taking this thing, so I'm drawing this graph only here. So I have to take the image of this whole portion from here to here to the top, and this portions we have to leave it as it is. So this portion image, how do we look like? So this will go at -1 comma -2 it was previously. It will go to 1 comma 2, because the image I have to take the depth, so it will go height. So it will go to 1 comma 2. Again this will hit here, because 0 comma -1 have the image 0 comma 1 there, and again this will go 1 comma 2 there and again come down. So in this way we have to draw the graph. So let's try it. So this will go here, again it will come down here, again it will go up here, and again it will come down here. And this portion was already there, and in this way we have drawn. So let's mark the point. This is -1 comma 2, this is 0 comma 1, this is 1 comma 0, sorry, 1 comma 2, and this is already there. Now I have to find the solution with x equals to 2, sorry, y is equal to 2. This right hand side is 2 here, so we draw a horizontal line 2 unit above. Where is 2 unit above? You can see it is here only, because this is the 2 unit above, and here we have to draw a horizontal line. It means if you draw a line there, it will directly pass to the points. So I have this, 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 and this. So these are the 4 solutions we can say for the equation. Let's go to the next question. Sine of mod x and is equal to mod x minus pi. So first we draw the graph of sine x, then we draw the graph of sine of mod x. How do we draw the graph of sine mod x? First sine x. So sine x is this, and we are drawing the graph of sine mod x. So for that, I told you sine of, if you take the modulus of x, what we think, now the x negative is also acting as a positive. So wherever you go on the left part of the y-axis, you have to carry the image of it in that portion on the right side. It means for this portion, I have this graph. For this portion, I have to take this graph, correct? So this will look like that. And whatever you see previously, these graphs are not anymore. I have to delete it. I've deleted it. And this is a graph of mod of. By the way, here there is a one little mistake I've done, but you can understand what I mean to say. All right. So this is, I have to erase. Let me erase it. Okay, now it looks better. And do the graph of sine of mod x. Now I have to draw the graph of mod x minus pi. So how do we draw the mod x minus pi? So graph of mod x shifted pi unit below. This value was already pi. This value was already pi. This value was 2 pi. This value was negative 2 pi, and so on. So mod x minus pi, so mod x will be there and it will shift pi unit below. So the graph of mod x minus pi will look like that, because if you substitute pi there, it will be satisfied. So it will hit this negative pi and pi at both ends. Therefore, there is only two solutions. We can also make change from here. Like suppose I want to keep this pi by 2, so it will sit somewhere else, and so on. Suppose I want to keep this not pi, I want to keep this sine of mod x is equal to mod x, then what will happen? The mod x graph will look like that, and the x is always above sine x for whatever angle. So it will go like this. And so this is only one solution we have. Anyway, let's move to this giant question. The question says that consider the equation for k belongs to R. The equation is 1 plus ln x plus e mod, and the whole mod is there, is equal to kx plus c. And we have to find out which of the following is correct statement. So for that, let's try to draw the graph of the left hand side of the equation first. And for that, I have the function to draw the graph of is, let us say fx is equal to 1 plus ln x plus e and the whole mod. So there are two mods, you can see that. The first is here, and then we have to add 1 to it, and then again one mod of it. So the idea, the plan is that first of all, we'll try to draw the graph of log x. Then we draw the graph of log mod x, and we shift the graph of log mod x e unit leftward. Because when we are adding the e from inside or any constant from inside, the graph will be shifted leftward by that number what you added. So first of all, we're drawing the graph of log x. So you know that the log x graph will look like that. This is the graph of log x. This is y is equal to ln x, and it will hit the x-axis at 1. So this point must be 1, 0. So this is the graph of log x, and the y-axis is the asymptote for it. Now in order to draw the graph of from here, I'm drawing the graph of y is equal to log mod x. So the log mod x graph, we have to take the image of the graph which we see on the right hand side to the y-axis to the left hand side to the y-axis also. And we have to keep the right hand side as well. So of course the graph of log mod x combinedly will look like this. We have to take the image of it. So maybe by hand it will be not so much symmetrical, but you can feel the understanding what I want to say. So this is the graph of log mod x combined with the green graph also. So let me just mark it. So this is now the graph of log mod x, all both together. Now we are shifting this entire two branches combined graph to the e unit leftward. So this is -2, this is -3, this is -4, and so on. This is 2, 3, and 4. I want to shift the entire graph E unit leftward. Where is E, by the way? E is a value 2.718. So it will be between -2 and -3. It means I'm marking somewhere here. Let's say this is E. It means this entire asymptote, what we see on the y-axis, should be now be shifted to this x equals to -E. So let me draw this line. So this length was E, but I have to say this is -E. So let me erase this thing, and then I'm writing this thing. Now I have to replicate these two branches, what we see here and here, around this x equals to -E. So I want to shift this entire graph to the left of this. I have shifted this part, and I'm also shifting this entire portion here. So this is now the graph of, you can see this is the graph of log of x plus E. So let me just write it. These two branches all together is indicating the log of x plus E after shifted. So y is equal to log of x plus E. I have to also make sure what are the points now. So this is not the point -1, 0 anymore. This point will be how much? How do we find this value? How do we find it? We have to understand. Let me erase all these things, and now we will see the new points. So this point is -E. If you see that if I add 1 to it, it means if I substitute this 1 there, I will get 0. So what value of x I have to substitute to get this whole effect as 1 in the argument of log x? So that will be -E plus 1. It means this value must be -E plus 1, and this value must be -E minus 1, because if you see -E minus 1 there also, if you substitute it -E minus 1, it will be the effect of like a log of mod of -1, and log of mod of -1 is log 1, so it will be 0 there also. Now one thing also you have to notice, that this point here is actually at 0, 1. It means when you're substituting 0, you are getting 1 there, it is for sure. So the same effect we have to see on the left to this x equals to -E line. So we are going from -E to 0. That means we are going E unit from -E to get this height. So I have to go again E unit before it to get the same height. It means this value what we are achieving at 1. So let me take the horizontal line. The value we are achieving, that is 1, is at -2e, because when you substitute -2e, it will become log of -e, the mod of it, and that will become log of e, and again it will give you the same height. So that is 0, 1. And if you want to be more precise for that, you have to write -2e, 1. All right. Now, after this, if you look at the question says that I have to shift this entire graph 1 unit above. So how do we shift the entire graph 1 unit above? We have to think. So what I'm doing, I'm just taking this portion and I'm shifting 1 unit above. So how we can do it? Let me just bring this whole picture down so that there will be space to draw it. So this is, I'm taking down here, and now I want to shift this thing. So when you take this 1 unit above, you can see what will happen. This value, what you see, is on the x-axis. Means -E, 1, e plus 1 is on the x-axis, When you're shifting 1 unit above this entire graph, this value will go there. So at negative e plus 1, I will have now the value 1. And this value, the 0, 1, will be shifted to 0, 2. So let's try to again shift this entire graph. It means when we shift it, this will go there, and the 0, 1 will go there at 0, 2. So how the shifting will happen? So I'm choosing a different color, and the graph should look like this. A little bit down. So let us say this point is 0, 2. And a similar graph I have to draw this side. So at that point it will hit at negative e, minus 1, it should hit this point. So I have to take care of this. So I'm taking this graph like this. And at negative 2e, the value should be 2 because it's symmetrical about that. So we can draw like this, it will hit here, and if I join them. So that is the graph of the log of mod of x plus e plus 1, or y is equal to 1 plus ln x plus e. So I'm erasing the previous graph so that our entire system will look a little bit cleaner. Now this is the graph from where we have to think ahead. Now after this, I need to draw the graph of the mod of this entire thing. So I'm taking the mod. It means when we are taking the mod of any graph, what we simply have to take care of. We are just thinking that we have to take the image of some portion, but where are those portions? Those portions should be below the x-axis. So we can identify which are those portions which is below. So we can see this is here the portion which is below the x-axis. This is also the portion which is below the x-axis, and we are going to take the image of these two portions on the other side of the x-axis. So we take the image, it will go like this, and here also we take the image, it will go like this. So now I am left with, if you can see, I am left with this portion which has already there. A little bit by hand, it's a little bit difficult to draw, but let me just be more precise. Again, this portion I have, again this portion I have, and this portion I have. And now I'm erasing the portions what was below the x-axis. So now I'm left with the graph of the mod of 1 plus log of x plus e, and this is the graph I need for the left hand side. Now there is one important thing I want to make you understand. I want you to understand this thing. How do we identify these 2 points where this graph is hitting the x-axis? You know, the previous point, this is minus e plus 1, was for the previous graph. This negative e plus 1 and negative e minus 1 is for this portion, log of x plus e. But now I'm adding 1. So how do we identify? My point is, how do we identify this point and this point? So let's try to think very analytically. We don't have to do any such kind of big calculation. Just think from the basic and you'll get the idea. I am looking for such a value of x where this 1 plus log mod of x plus e mod becomes 0. It means I'm looking for this whole thing becomes 0. It means that I'm looking for such values of x where this whole thing will become minus 1. And when the log of x plus e will become minus 1, By the way, let me rephrase the question. When the log of anything will become -1? When the input is 1 by e. Because when you substitute this whole thing as 1 by e, it will become ln of 1 by e, and so it will become -1. It means I need x such that it will give you the effect of x plus e as 1 by e. So I'm easily going to substitute x equals to e minus e plus 1 by e. If I substitute minus e plus 1 by e at the place of x here, this value I'm substituting here, minus e and minus e plus e will get cancelled, and we are left with 1 by e, and that will become log of 1 by e, which will give you -1, and this one will get you cancelled, and then we get the value 0. It means this number here, what we were looking for, is nothing but negative e plus 1 by e. And so there is no such big thing to understand that this must be negative e minus 1 by e. So in this way we can also find out where the graph is hitting the x-axis, and now the graph is complete. Now the point is, how do we solve this question? The question is, we have to find out the value, which of the following is true. So the first option is for k is equal to 0. This equation has 4 real loads. So k is equal to 0 means that the line I have, y is equal to kx plus e. It means the line must pass through 0 comma e. And where is 0 comma e? So 0 comma e is somewhere on the y-axis above 2. So this is 0 comma e, and the line must pass through this point. So let us try to think the first option. First option is k is equal to 0. If I set k is equal to 0, I am left with y is equal to e line. And y is equal to line e is a line horizontal, and it is passing through 0 comma e. And in this line you can see that it is intersecting the given graph in 4 real points. So of course that will give you 4 real solutions. So the first option is absolutely correct. The second one is, if k is positive, equation has at least one root. What is the meaning of k positive? K positive means that I must have a slope like this, the line like this, or maybe like this, or maybe like this, or maybe like this. It will never go from second quadrant to fourth quadrant. It will always go from first to third. So the slope is positive. It means I'm drawing the graph either like this or like this or like this. So if the worst scenario, also the graph can be drawn like this, it will hit the point 0 comma e here. I mean to say, every such example, I mean to say that I'm drawing the line passing through 0 comma e. So from 0 comma e, in the worst scenario, you draw the graph like this or the line like this, it will intersect the given curve at one point. It means that this is also true that at least one root is possible. So B is also correct. The C part is, for k less than 0, equation has at most 3 roots. Less than 0, it means now we are drawing the graph, the line 0 comma passing through 0 comma e, and it will look like this. So maybe we can also draw a line like this or like this, but not horizontal. Otherwise it will be, the slope is 0, and also not vertical. Otherwise the slope will become infinity. I need to have k less than 0. So you can see that if I'm drawing the graph like this, the line like this, these two portions of the graph is already there. Means I have stopped here drawing, but it will not stop here. It will go up very high also. It means there is 3 solutions. One solution here, 2 solution, second solution, and third solution. this portion of the graph will never be interacted by that line. This portion I'm highlighting will never be interacted by the line I'm drawing with the slope negative. But these three portions of the graph, the portion 1 here, portion 2 and portion 3, will be always interacted by the line which has a slope negative, and therefore it will intersected at 3 points exactly. So it should be the exactly 3 points, but if it is saying that is at most 3 points, at most 3 points means that not more than 3 points. So it is not more than 3 points means 3 points is already included. So we can say that it is also true. Alright, now for k is equal to 1, equation has exactly 2 roots. This is very interesting. For k is equal to 1, what is the meaning of this? If you say that k is equal to 1, I must have a line. Let me write it here so that you can see. So line is now for k is equal to 1, the line is x plus e. It means the slope is positive and the intercept is still e. So the line should pass through 0 comma e. It is already there, but also now this time negative e comma 0. So it is the point where the asymptote is hitting the x-axis. So the line will look like, because it's not just all the lines, it is unique line. So we can draw the graph like this. There is one catch, because we have drawn the graph by hand, and in this draw we can see that this one point is here, one point is here. So there is one intersection is for sure, which is here. If you can see the highlight, this branch is intersected for sure. So one point is a solution for sure. But how do we know that this graph, until we have drawn the graph exact on the scale, we cannot say that this is intersected or touched at this point also. So for that, we have to think carefully. So how do we think carefully? Let's see. If this is a point, for sure, it is lying between e and minus e plus 1. Now this point, if it is touched by the graph with the line y is equal to x plus e, that must be the point lesser than 0. So let us find out whether it is possible or not, whether touching is happening or not. So we have to think that whether these two equations are meeting each other or have a common solution or not, other than the value what we have already found here, which is below negative e plus 1. Now you see that this value I can make 0, where I can make this thing 0. If I substitute x equals to minus e plus 1, we have already seen it, it is this number. If I see minus e plus 1, this at this point this will become 0, and that point will that number will be left out on the left side, so that will become 1. Now try to substitute this number here also. On the right hand side, you get minus e plus 1. So minus e and minus will get cancelled, again 1. It means at minus e plus 1, the value they are getting 1. And you can also observe this with the graph, because you have shifted that graph 1 unit above only. And at this point, the red line is also taking the same value. It means it should touch this graph one time at minus e plus 1, and it should intersect the graph of the branch of this graph here at minus e plus 1 by below minus e plus 1 by e. All right, so in this way we found that this line is touching the graph or intersecting the graph or meeting the graph at 2 points. So therefore 2 solutions is for sure for that part also. So for k is equal to 1, equation has exactly 2 roots. So all the options are correct in this way. If we want to confirm this whole thing difficult too, let's go to the GeoGebra and see what is happening there for this particular question. So let's jump into GeoGebra. So we are in the GeoGebra now, and we have to draw the left side function first. So fx is equal to mod of ln, but there's a 1 also, so 1 plus log, and inside log there's a mod sign, so let me take that thing also, mod of x plus e. And you saw that here we had the same graph before. All right, now I want to draw the line y is equal to ax plus e, and automatically k will become the parameter or the slider. And you can see that if I fix the value of slider at 0, it's a horizontal line and it will be intersected by the curve in 4 points. So therefore the first option has 4 solutions. If I move the slider towards the positive side of the k value, I can see that at least one solution is there. You can see in this worst scenario I have one solution, but I may have 3 solutions also. If I move that this way, I may have 3 solutions. If I move this slider to the negative side of k, I cannot have see, this graph is intersected at infinity, so at least 3 solutions will be always there. They're saying that at most 3 solutions, so maybe we can make the conclusions not correct by the most thing, but I'm thinking that like it's given that at most bit not more than 3, but at least 3 is there only. So maybe we are not getting the 0 solution or 2 solutions, but we are getting exactly 3 solutions. So exactly 3 solutions is there. There are no such kind of 4 solutions we get, because for 4 solutions I have to make the k value 0. Anyway, now I have to also take k is equal to 1. So let's take here k is equal to 1 minus 1 0 0 0 2 0 2 1 5 6 7 8 9 1. So this is 1 there, and we can see that the graph is intersected by the line at 2 points. One is here for this branch and one is exact tangent. So in that case also 2 solutions are there. Alright, this is the way the modulus function can be operated, and the composition with the modulus function can be drawn and understood the question graphically. See you in the next video. In the next video we will be doing greatest integer function and the related transformation. Stay math active.